All right, so today in Algebra 2, we're going to finish up section 556. We're going to talk about using compositions to verify inverse functions. So it tells me that if f of g of x equals x and g of f equals f, g of f of x equals x, then you have inverse functions. So if you can do the composition of the two functions both directions and they always equal x, then you know that they are inverses. And that's how we prove them algebraically. So it says, find the inverse of f of x equals 2x plus 5 and verify the inverse is a function. Okay? So I'm going to first just make that instead of f of x, say y equals 2x plus 5. Remember, in order to find an inverse, we switch places with x and y. So x equals 2y plus 5. And then we solve for y, so x minus 5 equals 2y. And then divide by half. So I get y equals 1/2 x minus 5/2. So my f inverse of x is 1/2 x minus 5/2. Okay? All right, so now we want to verify that these are inverse functions. Okay? So we're going to do f of g of x. So I'm going to start with the first one. So f of g of x. So that's where I'm going to take my inverse and plug into my f of x for x. So 2 times 1/2 x minus 5/2, all of that plus 5. So distribute our 2. So 2 times 1/2 x gets me x minus 2 times 5/2 is 5 plus 5. The 5's cancel and I'm just left with x. So now I want to go the other direction, g of f. So now I'm going to take the 2x plus 5 and plug into the other one. So 1/2 instead of x, I'm going to plug in 2x plus 5. All of that minus 5/2. 1/2 times 2x gets me x. 1/2 times 5/2 plus 5/2 minus 5/2 is equal to x. Both equal x, so we have proved that they're inverses. So again, that's what we're going to continue to do down here. So, and it doesn't matter the order that you go. So first I'm just going to do f of g of x. So I'm going to take this one and plug in right there. So instead of x squared, I'm going to do the square root of x minus 5, quantity squared plus 5. I'm going to do my shortcut for quantity squared. So that's the first one squared. So that's square root of x squared is x. Multiply the two together and double it. So minus 10 square roots of x plus 25. And then plus 5 at the end. So I've got x minus 10 square roots of x plus 30. This is not equal to x. Therefore, they are not inverses of one another. Okay? So now I'm going to go to the next one. f of x equals 1/4 x plus 7, g of x equals 4x minus 7. So again, I'll just do f of g to start out with. So 1/4 instead of x, I'm going to plug in 4x minus 7 because I'm taking all of this and plugging in right there, and then finish writing that out plus 7. 1/4 times 4 gets me x minus 1/4 times negative 7 gets me minus 7/4 plus 7, not equal x. Again, therefore, they're not inverses. Okay. The first one is not equal x, then I don't even have to check the second one, right? Number 3, f of x equals the cube root of x minus 1, g of x is x cubed plus 1. So again, f of g of x. So take this, plug in right there for that x, so the cubed root of instead of x, the x cubed plus 1, all that minus 1. So now underneath there, the 1's cancel, and I'm left with the cubed root of x cubed, which is equal to x. So that one checks out. So now we want to go the other direction, g of f of x. So take all of this and plug in right there. And so I have the cubed root of x minus 1, the cubed plus 1. When I cube the cubed root, I just get what's underneath, x minus 1 and plus 1, which equals x. Therefore, they are inverses. Okay? So that's how we determine if two functions are inverses of one another. Take the composition both ways. It doesn't matter if I do f of g or g of f. Okay. As long as they both equal x, then they are inverses of one another. All right, the last thing that we need to look at in section 5.6 are word problems. So we're going to rewrite a formula. So it tells us that a sculpture artist is making an ice sculpture of Earth for display. He created a mold that can hold 4.5 liters of ice. What will the radius of the ice sculpture be if he fills the mold all the way? So this is a sphere. So let's remind ourselves the volume of a sphere is equal to 4/3 pi r cubed. Okay. We want to solve that for the radius. So we're going to solve for the radius because that's what they're asking us to find. So I need to get rid of my 4/3 pi. So to get rid of the 4/3, flip and multiply. So really I have 3/4 v equals pi r cubed. Right? Divide by pi. So I get 3v over 4 pi equals r cubed. And then take the cube root of both sides. So our radius is equal to the cubed root of 3v divided by 4 pi. So there's the formula for the radius. So now I can't just plug in 4.5 liters, okay? Because liters is a measure of capacity, okay? Radius is going to be a unit of length, okay? So again, let me write that. Liters, measure of capacity. The radius is going to be a unit of length. So I need to change the liters into a unit of length. Okay, so we're going to do centimeters. So the conversion rate, 1 liter is equal to 1,000 cubic centimeters. We're going to use that. So then if 4.5 liters, I need to multiply that by 1,000. It's going to be 4,500 cubic centimeters. Okay, so that's the volume we're going to use. So now we're going to plug that into our formula that we just came up with for the radius. So radius equals the cube root of 3 times 4,500 divided by 4 pi. When we work all of that out, we find that the radius is approximately 10.2 centimeters. And the last word problem. The manufacturer of a gift box designs a box with length and width each twice as long as its height. Okay, so the length is 2 times the height. The width is 2 times the height. Find a formula that gives the height h of the box in terms of its volume v. Okay, we know that the volume of a rectangular prism, right, length times width times height. So using 2h for length and width, I can say volume equals 2h times 2h times the height. So our volume would be 2 times 2 is 4, h times h times h cubed. So now it says the height in terms of its volume. So we want to solve this for h. So if I solve that for h, divide by 4, so I get v divided by 4 equals h cubed, take the cube root. So h is equal to the cube root of v divided by 4. And now it says, then give the length of the box if the volume is 640 cubic centimeters. So now I'm just going to plug in 640. So h equals the cube root of 640 divided by 4. When we work that out, we find that the height is approximately 5.43 centimeters. They asked us for the length. The length we said was 2 times the height, so 2 times 5.43. Our length is approximately 10.86 centimeters. All right, that finishes up section 5.6. Our homework will be over the 5.6 worksheets that you can find on Canvas that you've been working off of. And then I will also have that test review. The test reviews for you, our tests will be Tuesday and Wednesday.